Hello, class. Today we're going to be going over reflections, okay? So let's start with our definition. So the definition for today is a reflection. So reflection is a transformation, kind of like a slide, except this time, instead of sliding our figure around our x and y axis, what we're going to do is we are going to flip our figure across an axis of symmetry. And that's called a reflection. So a reflection is a transformation where you flip your figure across an axis of symmetry. Now, the big key topic here. If your point is a certain distance from the axis of symmetry, your reflected point is going to be that same distance from the axis of symmetry. So if my point is 2 units to the left of my axis of symmetry, my reflected point is going to be 2 units to the right of the axis of symmetry. If my original point is 5 units above the axis of symmetry, then my reflected point will be 5 units below the axis of symmetry. Okay, so notice when we have our reflection here. Now let's look at our points on the x and y axis. So first on the left is our figure, our A, B, C. That is our original figure. And on the right side, the A prime, B prime, C prime is our reflected figure. So notice how these figures both look congruent. They look the same shape, they have the same angles, and their side lengths are the same. What's different is we have flipped this point across the y-axis. So let's look at some of these points here. Let's notice the point A here. So the point A is 1, 2, 3, 4, 5 spots from our axis of symmetry. So that means the point A prime is going to also be 1, 2, 3, 4, 5 spots from this axis of symmetry. Same thing holds true for the B. The B is 1, 2 spots from the axis of symmetry. So my B prime is 1, 2 spots from the axis of symmetry. And lastly, the same holds true for our C. Our C is 1, 2 spots from the axis, so the C prime also has to be 1, 2 spots from the axis. Alrighty, so let's go into a quick question here. I want you guys to think about this on your own. So which one of these shows a reflection? Is it this one over here on the bottom left? Is it the one in the middle? Is it the one slightly right here? Or is it the one on the far right? I want you to think for a second, which one of these figures shows a reflection? All right, so the figure that showed the reflection in that one was the figure on the far left-hand corner here, this one right here. And the reason is because all of the points share the same distance from 0. And it looks like it's flipped over this y-axis right here. Notice on the second figure, the points do not have an axis of symmetry they're flipping over. Instead, we are sliding them in a different direction. So this one right here is a translation. This third one right here, even though we haven't learned it yet, this is called a rotation because the figure is rotating around a point and it's changing its shape there. And lastly, we're not going to really learn about this one here, but this one is called a dilation or an enlargement because the figure is starting small and then we were making it fractionally bigger. But the one that was a reflection was this first one right here because all of those points shared the same distance from 0. Okay, so how do we perform a reflection? So to perform a reflection, you need to count how many spaces your points are from the axis of symmetry. So let's start off by graphing some points. Let's graph the point A, which is at negative 2, 2. So I need to go to the left 1, 2 and up 1, 2. The point B, which is negative 2, negative 2. So to the left 2 and down 2. And the point C, which is negative 5, 0. So to the left 1, 2, 3, 4, 5, and then up or down 0. So this is our original point here. It's our A, B, or C. And we need to reflect it across the y-axis. So remember, the y-axis is the vertical line, the one going up and down here, or you could just clearly see it is labeled y. So we need to first count how many units away from our axis of symmetry are. So this first point right here is 1, 2 spots away from my axis of symmetry. So I need to go 1, 2 spots in the other direction. My point on the x-axis is 5 units from the axis of symmetry, so I need to go 1, 2, 3, 4, 5 units in the opposite direction. And this point right here is, again, 1, 2 spots from the axis of symmetry, so I need to go 1, 2 spots in the other direction. And that right there is how you reflect your points across a y-axis. Notice how our figure stays exactly the same. It still has all the same side lengths and angle measures. The only new difference is it has been reflected across a line there. So all of those points share the same distance from your axis of symmetry, which is how you know this figure was reflected correctly. Okay, so I want you to think, how can you compare the original image and the reflected image? What can you say about those two figures? And also, these can be called the pre-image and the image. The pre-image is the one we have not moved yet, and the image is once we have reflected. So try to think for a second. How can you compare the original image and the reflected image? All right, so if you were answering that one there, I would have liked you to say something like the original image and the reflected image are congruent or the same. They make up the same figure, they have the same side lengths, and they have the same angle measures. So those two figures are congruent. And again, congruent means these figures are the same. It's just like a translation or a slide, where wherever we slide our figure on our X and Y axis, it'll remain the same, it'll remain congruent. Just like whenever we flip our picture, it'll remain the same, it'll remain congruent. All right, so this is basically the same thing here. Original images and reflected images are, it's congruent is what I'm looking for here, congruent or the same. All right, so for this one, we want to reflect the points that we can see in this figure here across the y-axis. So I want you to try this out on your own, pause the video, and then unpause it so that way you can see how I do it here. So this point C is how many units from our y-axis. So there's 2 spots from our y-axis, let's say, we have to go 2 spots in the other direction. Same with our A's and our B's. The A is 5 units from the x-axis, the y-axis, so I need to go 5 units to the right. My last point here, B is 3 units from my y-axis, so I need to go 3 units to the right here. So this would be my new C point, or my new A, B, and C, my new figure. It looks exactly the same, but we have reflected it across the y-axis, which means that my points are, C is at the point 2, 5, A is at the point 5, 2, and B is at the point 3, 1. Alrighty, everybody, that was about it for our notes today, so make sure you write yourself a 2-sentence conclusion here. We want to talk about what we learned today, so that was our last slides. Hopefully this was able to help you out. If you guys have questions, make sure to bring them to class tomorrow. I'll see you all then. Bye-bye, everyone.